Hello there. My name is David Evans and I am the Research and Development Director at CADlink Technology. And I'm going to be looking at methods of printing white and clear ink with digital printers such as inkjet and a new process to simplify the workflow. UV and the DTG marketplace are the two areas where white and clear get used most. There are over 10,000 DTG printers now sold with white ink in the world, and this now makes it a fairly well established and mature market. The UV desktop printer market is a market that's growing at a considerable pace, and it's certainly already well into its thousands with white and clear. And looking at the number of manufacturers, both at this show and in the last 6-9 months, that have brought out new desktop machines with white and clear, I think it's obvious that that's a very, very large growth market. This is for promotional materials such as USB sticks, pens, and most of all, phone covers. With billions of phones being sold every year, and the people who have phone covers often changing their phone covers once every 6 months, the potential for personalized phone covers is literally in the billions. We have sold a lot of software with machines that do nothing but phone covers. The interesting thing about printing with white and clear is that it's a new technology, and with new technologies it causes new issues. It creates the biggest problem is the file preparation. The file preparation required for production, requiring where you want to put the white or where you want to put the clear, adds additional time and costs. It also increases the chances of errors. You need to control how much white goes down, so there's production issues. And there are obviously cost involvements of using white and clear. They tend to be more expensive than your traditional CMYK inks. So using these efficiently can have large cost savings over a long period of time. In this illustration here, we look at a typical graphic you might want to print. On the very left-hand side, we have the original PDF file. Shows you then the actual image you want to print and how the white underbase would look underneath that. The problem is, how do you define that white? How do you tell the software, the printer, this is just the area you want to print the white? And that's the area we're going to be looking at, a way of simplifying that process. First of all, I'm going to look at the current methods. There's 3 main methods for doing this today. One common way is to use something called valid pixel. Valid pixel says that any area, any location which is not white, not pure white, we will print the white underneath it. It does require a file preparation still, as it means any white text or anything like that you have to turn into a tint. You have to give it a 1% or a 0.5% yellow so that it's not pure white. A 0.5% yellow won't show up, it'll still look like white, and it allows the RIP software then to identify that. But it does involve editing the artwork first, and it is also limited to what I call hard edge graphics. In other words, there's no way of doing a gradient of white to fade into whatever your substrate is. You basically have white on or off. Second way of doing it on here is the transparency method. The transparency method is pretty much the industry standard in the DTG industry for printing white ink. With transparency, what we do is we say if it's transparent, we don't put any white down. If it's opaque, we put white down. This allows you to do gradients and things because you can have something that's 50% transparent, in which case you'll get 50% white down. And as I said, this is commonly used now throughout the DTG industry and has been for many years. The downside of this is that the system relies on converting everything first to a bitmap format, basically a PNG, TIFF or PSD. It means that any named spot colors, you won't get any color matching because there is no such thing as named spot colors in bitmaps. It also means that you're going to have to arbitrarily rasterize your data to 300, 400 dpi. So if you're printing pens or USB sticks or even phones with small text, you need to create quite large files to get the text to look half decent. The third and last way of doing this is to use spot colors in Illustrator and so forth, like your Pantone palettes. And you typically create, you have a spot color like a named spot color might be white, and you draw objects and you give them that spot color attribute, and then you make them something called an overprint. This allows you to do everything you want to do with white, but the file then becomes very device dependent for that specific device, and obviously involves quite a lot of artwork. If you're in a production room and you've got a customer file, you've then got to go to your graphics art department to generate the white if the file hasn't been generated white. And I can pretty much tell you from experience, the customer files that you're going to get will never have the white set up for you. It's just not going to happen. So all of this artwork preparation is going to increase your costs. It limits the users and the sorts of people who can actually use these methods because they have to have higher levels of knowledge. It increases the chances of mistakes in the output. Anytime you've got to edit the artwork or make changes to the artwork before you start doing your output is going to increase your chances of mistakes and their costs. And what you really want, what everybody really wants, is to make this like CMYK. You just want to print just like you do to your desktop printer or any other large format printer. You just want to be able to print it out and not have to worry about how to generate the white. And so that was our aim. And it can be easy. What we have and what we start with is a queue-based system. You have different queues. They might be for CMYK only or white on CMYK, CMYK on white, clear on CMYK, or even more complicated layering systems like white, CMYK, and then clear. And what we do is we create a queue-based system, and each queue is configured automatically to give you those different layers automatically. And all you then have to do is to take your PDF or EPS file, and it can still be a bitmap if you want to, drop it on the queue, and these queues are basically presets, and when you print with that queue, it will automatically generate the white just where you need it, or the clear just where you need it. So how does it do this? It does it from a very simple approach. In fact, what we do is we use the opacity of the objects in the data. So what I've got here is an illustration of a PDF file logo. And on the left-hand side, I've drawn a blue box behind it. So what you can see is when you're looking at that blue area, that's where it's transparent. And you can see the rest of the objects, the whole of the logo itself, is opaque. So what happens is that we have a specially modified PostScript PDF interpreter that feeds back the opacity of the graphics. So you don't have to worry about white, whether something's white or not, where you print the white, because only if you've drawn a white object will you get the white behind it. Where there's no objects drawn, it'll be fully transparent. It also means that by using the transparency information, the graphics designer has full scope to do gradients, blends into the substrate, or whatever they want to create a very integrated graphic into the t-shirt, bottle, whatever it is they're printing on, phone cover. So this is a very simple approach because the graphic artist doesn't need to even understand he's going to print white. All he's got to do is just design the way he normally designs, 90+%, most of your graphics that exist, most of your clip art can just be used as is. It is as literally like you just create your CMYK artwork and you can send it to the printer. Here I've got an illustration of a famous logo where it's got a shadow, a soft shadow. So again, I've done a blue background so you could see what it would be like on a blue background. The guy's going to design this, he wants the shadow. Let's say you're going to print this onto a bunch of iPods on the back of them. And let's say the iPods were in yellow and green and blue and pink and all these other colours. On the right hand side you can see how the underbase is going to be generated from that. The soft shadow is semi-transparent. So your soft shadow is going to work in exactly the right way. You're going to get a bit of white down there, and then your shadow is going to, CMYK is going to go over the top to give you that dark shadow. So it doesn't matter whether you've got a yellow iPhone or a blue iPhone or a cyan iPhone, you will get where you want the white and green objects, they're going to be opaque, they're going to have solid white behind it, and where you have the shadow, you're going to have a shadow showing through the color of the iPhone still. So it becomes nicely integrated. And this is the same graphic that you can print for CMYK. Designers don't need to know about spot colors, overprint, valid pixels, or anything else. And the white will always reflect what the designer had in mind. It also means that because we're working with the PDF file, that spot colors, name colors like Pantone matching and all of those things can still be applied. In order to have our preset cues, we have configuration options. On the left you can see we have layers. In this particular case we have 2 layers. One is underbase and one is color. Each layer will show you all of the channels that the printer can output. So for example, on the underbase layer we just want to print the white. On the color layer you would see we just printed the CMYK. And then on the right hand side you can see I have what we call our processing options. So by selecting an underbase, what we're saying is when you process this file, generate the white, gather that information and use that information to print a white underbase automatically. And that's how it works behind the scenes. You can have as many layers as you like. So that's why you can build things up. So if you need to hit an underbase on some UV machines, the white may not be particularly opaque. If you need to hit the white twice, you can hit the white twice or 3 times or as many times as you need to build up that white to get the opacity you need for the particular substrate you're printing on. There are other individual processing options. I'm not going to go through all of these, this is just an overview. But you can have things like alignment issues, particularly when you're doing multiple passes. So we have the option to automatically choke all the white. So you can choke, this is a complex choke system. If you've got just the white objects, it won't choke. It'll only choke where there is color above the white objects. You can choose to control the maximum white density. And for the clear, you can also spread the clear. And generally speaking, you don't want to choke the clear, but sometimes you want to spread it a little bit further. So working from transparency is a natural, intuitive way. It's part of the design. Your existing graphics can work without any changes. There's no requirement for the print production to understand graphics editing, which is a big plus for any larger shop. There's no requirement for an in-house expertise on designing. We're working with Illustrator and InDesign and other packages. Using PDF means that your text and vector will be output at the resolution of the device to give you the very highest quality. Spot color matching can still be applied, and there is no flattening required of transparent areas. In fact, we don't want you to do pre-flight or flatten the transparency because it's the very transparency information that we use to generate the white. There's also no color shifts. If you have a PDF file that maybe comes from InDesign that has a mixture of CMYK, RGB and other color spaces, you're not having to convert them to a bitmap first, which we're going to normalize them. we can still render them from their original color spaces to the output color spools. So you're going to get better color matching. Well, that's really the overview. If you'd like more information, you can come and talk to CADlink at stand F31A in Hall 8. There are some samples here if you want to see the sorts of output that this can do. This is a t-shirt created from an Illustrator PDF file where you can see the gradients, and if you want to come up and have a look, pass it around, you can see how nicely it blends into the shirt. And the same thing can be done on any coloured shirt or onto other coloured substrates. Do you have any questions? No? All right, thank you very much.